This demo illustrates the effect of applying a bilateral filter to test and training images of the histogram of oriented gradients machine learning algorithm that classifies regions of images as containing fruits and not containing fruits. The bilateral filter takes regions of the image that are similar in color and blurs those regions while preserving the high contrast areas of the image. So you can see in the upper half of this graphic, we minimize the effect of this discoloration in this individual longan fruit and also these specks here. And this is the resultant image where the fruit itself is blurred, but there is no blur. In fact, there's even less blur than there previously was on the boundary of the fruit. And the effect that this has on the histogram of oriented gradients feature descriptor is to align these gradient vectors in a similar direction and ultimately making the regions of this image where the fruit exists more similar to other such regions where other fruits exist in the image, and also making regions where the fruit exists different from regions of the image where the fruit does not exist, which would exhibit this kind of rough, patchy look. So if we look at, I've prepared two pre-trained models of the support vector machine, which takes as input the histogram of oriented gradients descriptors and classifies images, regions of images, as longan fruit or not longan fruit based on those descriptors. And I want to simply illustrate the increase in the accuracy of the algorithm when we apply the bilateral filter versus when we don't. So in this case, we are going to apply the bilateral filter. And in a second case, we will not apply the bilateral filter. And so you can see that as the sliding window moves across the test image, detections with a certain probability of likelihood are being made here, and will soon appear here. Now, to execute this algorithm takes some time, and so I actually ran it in advance, and I will simply show you the outcome. So if we do not apply the bilateral filter, you can see that there are many occurrences of false positives. So this is not a longan fruit, this is not a longan fruit, here is not, here is not, here is not, and so on. There are many, many occurrences where the region of the image is rough and similar to the training data where the fruits were themselves rough. If we look alternatively at the result of performing classification on the smoothed, filtered training image, you can see that many false positives have disappeared, and of course a couple have appeared, but overall we can see the distinction. So I will cancel these. Thank you very much.